All right, let's dive right in. Today, we're going to pull back the curtain on a really powerful way to build applications. We're talking about event-driven serverless architecture on Google Cloud. It's a method for making apps that are not only super reliable, but can also scale up to handle pretty much anything you throw at them. But first, let's talk about something we've all felt. You've been there, right? You find the perfect thing online, you hit that buy button, and then the spinning wheel of death. Or even worse, the page just crashes. You ever wonder what's actually going on behind the scenes when that happens? Well, a lot of the time, the answer is all about how that system was built in the first place. So, to really appreciate the solution, we first need to get a good look at the problem. Let's explore what I like to call the old way of doing things, the tangled checkout system. So traditionally, all the different jobs in a checkout process, handling the payment, checking the inventory, getting shipping ready, they were all kind of mashed together in one giant single application. Think of it like a metal chain. If just one single link in that chain breaks, maybe the inventory check fails for a second, the entire chain snaps. The whole process just grinds to a halt. It's incredibly fragile. And this really gets to the core of it. On one side, you've got that old way, brittle, super complex, and just asking for trouble when you get a sudden flood of orders. But the new way, it's promising something so much better, a system that's resilient, that can scale almost forever, and is built from simple, independent parts that don't drag each other down. So, how do we get from that tangled mess to this beautiful new world? Well, it takes a pretty fundamental shift in how we approach our applications. We have to start thinking in events. Now, event sounds kind of fancy, but it's just a word for something that happened. That's it. A customer placed an order, that's an event. A payment got approved, that's another event. A photo was uploaded, yep, that's an event too. In an event-driven world, the different pieces of your system don't talk directly to each other. Instead, one piece just announces, hey, this thing happened, and other services can choose to react to it. They're what we call decoupled. A great way to picture this is like a relay race. When an order is received, that's the starting gun. That event triggers the payment service. As soon as the payment is done, it passes the baton, triggering the inventory service. Then, inventory hands it off to shipping. See how that works? Each runner does their one specific job and doesn't need to know a thing about the other runners. It's just a clean, smooth, sequential flow. Now, to actually build this relay race on Google Cloud, you're going to need a team of specialized services. This is your GCP serverless team, and every single member has a very specific job to do. Let's think about this whole thing as a new, super efficient factory. Instead of having one person frantically trying to do everything at once, you have a bunch of specialized workers who are absolute experts at their one single task. That's really the heart of the serverless idea. And here's our factory team lineup. Cloud storage, that's your loading dock. It's where all the raw materials, like new orders or files, first arrive. Then you've got PubSub. This is your tireless factory messenger, a super reliable system that makes sure every worker gets the right memo at the right time. Your actual workers on the factory floor, those are Cloud Functions or Cloud Run. You can think of functions as the pros for small, single-purpose jobs, and Cloud Run for running whole containerized apps. And watching over the whole operation is Cloud Scheduler. He's the factory manager, making sure everything that needs to happen on a schedule happens right on time. Okay, this all sounds pretty great, but, I know what you're thinking. In the real world, things break. Stuff goes wrong. So what happens when our perfect little factory hits a snag? We absolutely have to plan for failure. And this is the million-dollar question, right? What if the payment service has a little hiccup or a message from PubSub gets delayed? Does the whole relay race just fall apart? Is that customer's order now lost forever in some digital limbo? The first safety net we have is a concept called idempotency. I know. It's a huge word, but the idea behind it is actually really simple. Doing something more than once shouldn't cause a problem. Think about it. Charging a customer's credit card twice? That's bad. But setting an order status to paid twice? No harm done. Building your functions to be idempotent like this is absolutely key for being able to safely retry steps that fail. So how do we actually handle those errors when they pop up? Well, our first line of defense is retries. The system just automatically tries the failed task again, hoping it was just a temporary glitch. But you can't just try forever, right? That's where a dead letter queue, or DLQ, comes into play. If a message keeps failing, it gets safely moved over to this special holding pen, which lets a real human investigate what went wrong later, all without shutting down the entire factory.
Okay, now that we've got the concepts down and we have our safety nets in place, let's look at 4 powerful, super practical patterns you can start using on GCP today. Think of these as proven recipes for success.
First on the list, the storage-triggered workflow. This one's a classic. A user uploads a new profile picture to cloud storage. That upload, that event, immediately kicks off a cloud function that resizes it into a thumbnail. The beauty of this is how direct it is. You don't have to write any complicated code to constantly check for new files. It just happens. Second, we have asynchronous messaging. This is the secret sauce for how major retailers survive things like Black Friday. The website simply fires an order received message to PubSub and instantly tells the customer, hey, thanks for your order. It doesn't sit there and wait for the payment and inventory and shipping to finish. No, those backend services just pick up messages from the queue and work through them at their own pace. This is what lets them absorb these massive, sudden spikes in traffic without the user-facing website ever crashing. Third up, scheduled tasks. You know, not all events come from users. Cloud Scheduler is basically your system's personal alarm clock. It can kick off a function to generate sales reports every night, run heavy data jobs when the system load is low, or even send out daily email newsletters, all without any human having to lift a finger. And finally, we've got our most advanced pattern, event-driven pipelines. This is where the successful finish of one task becomes the event that triggers the next one. So, a video file gets uploaded, that triggers a function to transcode it. When that's done, it fires its own event, which triggers another function to pull out metadata, which then triggers a final function to update a search database. You see, you can build these really complex workflows out of simple, independent, and best of all, easily testable little parts. So, what's the big takeaway here? When you boil it all down, by thinking in events and using these serverless tools, you get to build systems that are decoupled, so a failure in one little corner doesn't cause a total meltdown. You get applications that are resilient, with built-in retries and error handling. And you get systems that can scale, seemingly effortlessly, to handle any amount of traffic you can imagine. And that brings us to the end. These patterns, they aren't just theory. They're actual blueprints you can use to build better, stronger, more scalable applications right now. So I'll just leave you with this question to chew on. What problem in your own projects or your own work could you solve by starting to think in events? Thanks for joining me.